Welcome to the Military Breakdown Podcast.
Great to be here.
Today we're taking a really detailed look at the V-22 Osprey. You sent in some fascinating material on this.
I did. It's quite the aircraft.
It really is. And our goal today is, well, to unpack the complexities, right? The hurdles it's faced, but also the plans for its future.
Absolutely. From the challenges to the innovations.
Let's try and get the full picture. So where should we start? I guess safety often comes up first, doesn't it?
It does. And it's important to look at the actual data. The MV-22, the Marine version, its 10-year average mishap rate is around 3.43 per 100,000 flight hours.
Okay, 3.43. How does that stack up?
Well, interestingly, while any number sounds concerning, that actually puts it kind of in the middle range compared to other Marine Corps aircraft. It's not the highest, not the lowest.
That context is key, yeah. Because you hear about incidents, and it paints a certain picture.
Exactly. And since it started flying operationally back in 2007, there have been 14 total losses of aircraft. That's across all the services using it, plus Japan.
14 losses since 2007. And of course, there was the recent grounding. That really brought it back into the headlines.
It did. That followed a tragic crash of a U.S. Air Force CD-22 over in Japan.
Right, and the initial reports pointed towards a gearbox issue.
Correct, a gearbox failure. And what's emerged since then is, well, concerning. Reports indicate defective steel from a subcontractor might be linked to that specific crash.
Wow, defective steel.
Yeah, and potentially others too. It really underscores, the whole supply chain vulnerability aspect.
Yeah.
Quality control is just critical.
Absolutely. So with these very real concerns, what's actually being done? What are the steps to address this?
It's definitely a major focus. The Marine Corps is pushing forward with several initiatives. One really significant one is called ODSASI.
ODSASI, okay, what's that?
Stands for Osprey Drive System Safety and Health Instrumentation. Bit of a mouthful.
Yeah.
But basically, think of it like adding a really advanced diagnostic system. They're installing vibration sensors inside the Tiltrotor gearboxes, those big tilting units.
Own core mechanism.
Exactly. And in the drivetrains, too. The idea is these sensors will pick up tiny vibrations that could indicate a part is starting to fail.
So it's predictive, like an early warning system.
Precisely. Allows for proactive maintenance, getting ahead of a potential failure instead of reacting after something breaks.
That makes a ton of sense, just moving away from waiting for things to go wrong.
The big shift. And alongside that, they're also looking at the materials themselves.
Right, you mentioned the potentially defective steel earlier.
Yeah, so suppliers are being directed to use a more durable type of steel. It's called triple melt steel.
Triple melt. Sounds robust.
It is. The goal is to build more inherent resilience into those internal gearbox components, reducing the chance of material defects causing problems down the line.
Okay, sensors and better materials. I also read something about an issue called hard clutch engagement, HCE.
Yes, HCE. That's another focus area. Essentially, it's when the clutch mechanism that connects the engines to the rotors engages too abruptly, too forcefully, especially during that transition between helicopter and airplane mode.
Okay, and that sudden force can cause damage.
It can put a lot of stress on the drivetrain, potentially leading to damage over time. They've linked this issue primarily to a part called the Input Quill Assembly, the IQA.
IQA, got it.
So the plan is to actually redesign that IQA component to make the clutch engagement smoother, less jarring.
So tackling it from multiple angles, monitoring materials and component design seems comprehensive.
They're certainly trying to cover the bases to improve that reliability and safety record.
Now, looking a bit further out, the Marines are apparently getting close to receiving their final V-22 orders, right? Deliveries ending maybe 2026?
That seems to be the timeline, yes. The final orders are likely in, and deliveries wrap up in the next couple of years.
So if they're not buying many more new ones, the focus must shift pretty heavily to the existing fleet.
Absolutely. It's all about sustainment now. The plan is to keep these Ospreys flying for decades. We're talking well into the 2050s, maybe even pushing towards 2060 or beyond.
Wow, 2060. That's a long life for an airframe, especially one this complex.
It is. And achieving that requires a really robust plan for both ongoing maintenance and, crucially, modernization.
And part of that plan I saw involves trying to get more commonality between the different versions, the Marine, Navy, Air Force, Ospreys.
Yes, that's a key goal. Achieving a more standard configuration across all the fleets.
Why is that so important?
Well, think about logistics. If the parts are more common, maintenance procedures are more similar, training can be streamlined, it just makes everything more efficient.
Right, economies of scale. Fewer unique parts bins, simpler supply chains.
Exactly. It reduces complexity and ultimately should bring down costs.
Makes sense. What about upgrades? I saw mention of software playing a big role.
Software is huge. The plan is to bring all the U.S. military V-22s up to the same software baseline. They're talking about moving towards a software-defined platform.
Software-defined. What does that mean in practice?
It means a lot of the aircraft's capabilities become more dependent on software than specific hardware. The really interesting part is how much faster they think they can roll out new capabilities.
Faster updates. How much faster?
They're aiming to cut the time down from maybe 4 years currently to something like 18 to 24 months.
Wow, that's a massive improvement.
It is. Imagine being able to integrate new sensors, communication systems, or countermeasures much more rapidly, just during regular maintenance periods. It adds a lot of agility.
Definitely keeps the platform relevant against evolving threats. Is the cockpit getting a facelift too?
It is. There's a program called Vector V-22 Cockpit Technology Refresh.
Vector, okay.
The idea here is to leverage more modern, commercial, off-the-shelf technologies. Think things similar to what you might find in, say, a modern business jet.
Ah, so replacing older, maybe harder to source military-specific displays and processors?
Exactly. It's partly about tackling obsolescence, finding replacements for aging components, but also about reducing the maintenance burden and cost associated with those older bespoke systems.
So potentially more reliable, easier to maintain, maybe even more user-friendly for the pilots?
That's the goal. And sticking with maintenance, Bell and Boeing are also developing a dedicated vibration monitoring system specifically for the gearboxes.
More sensors, like the ODSSHI thing.
Similar concept, but maybe more focused specifically on the gearbox health, given its history as a problematic area. Things like Sprague clutch slips have been issues.
Right.
So this system will give them a much clearer picture of the health of individual components inside the gearbox, again, enabling that proactive, condition-based maintenance approach.
It really sounds like data is driving the future of keeping these flying safely.
Very much so. It's about understanding the machine in minute detail.
Now, you mentioned flying into the 2050s, maybe 2060s, but I also saw something about an even bigger potential overhaul, maybe in the 2040s. Revamp-y.
Yes, Revamp-y, the renewed V-22 aircraft modernization plan. This is a more significant, more structural upgrade package being considered for further down the road.
Structural? Like, what are we talking about?
Oh, we could be talking about replacing major components. Things like the wings, the engine nacelles, the pods holding the engines and rotors.
Replacing the wings, wow. That's almost like building a new aircraft on the old fuselage.
It's getting close, yeah. The idea is that by replacing these life-limited structural parts, you could potentially extend the service life of the core fuselage significantly further, maybe even into the 2070s.
Into the 2070s. That's incredible. Is that feasible?
Well, studies are underway right now to figure out the feasibility, the scope, and of course the cost of doing something that extensive. It's a major consideration for the long term.
A huge investment decision down the line. But even with all this focus on keeping the V-22 viable for decades, they are still thinking about what comes next, eventually.
Oh, absolutely. You always have to be looking over the horizon. The Marine Corps has formally acknowledged the need for a successor aircraft. It's called the Next Generation Assault Support Program, or NGAS.
NGAS. Okay, so that's the official name for the Osprey replacement effort?
Correct. And it's now actually documented in their 2025 aviation plan, so it's formally on the books as a future requirement.
Do we have any idea of the timeline for NGAS?
It's still fairly early days. The forecast is for the capability development document, basically, the detailed requirements list, to be ready in the early 2030s.
Early 2030s.
And then the actual research, development, testing, and evaluation phase, RDT&E, could potentially kick off in the mid-2030s. So we're still looking maybe 10, 15 years out before we see serious hardware development.
Still a ways off, but the planning is starting. Are they looking at specific technologies? I know the Army just picked their new assault aircraft.
They are definitely watching closely. The Marines are monitoring the Army's FLRAA program, Future Long Range Assault Aircraft, which, as you said, selected Bell's V-280 Valor Tiltrotor.
Another Tiltrotor. Makes sense they'd watch that.
It does. But they're also looking at developments coming out of DARPA, the Defense Advanced Research Projects Agency, and what industry is cooking up more broadly. Things like high-speed vertical takeoff and landing concepts, HSVTO. Yeah, concepts that aim for even higher speeds than current tiltrotors while still retaining that vertical lift capability. The Air Force seems particularly interested in those as a potential replacement for their CV-22 Special Operations Ospreys.
So it's not necessarily guaranteed to be another conventional tiltrotor like the V-280. They're keeping options open.
It seems so. At some point, they'll face that crucial decision. Keep investing heavily in V-22 upgrades like Revamp E, or pivot resources towards developing and fielding NGAS, whatever form it takes.
A classic defense procurement dilemma. Okay, let's shift gears slightly. We've talked a lot about the tech and the future, but how is the Osprey actually used today? How vital is it operationally?
Oh, it's absolutely central, especially for the Marines. The MV-22 is classed as a medium heavy lift aircraft and is the backbone of their Marine Air Ground Task Force, the NGTF operations.
Then GTF, right.
Since 2007, think about this, 109 operational deployments.
Yeah.
Over 588,000 flight hours logged. That's a lot of real-world use.
500,000 hours easily. That's
Yeah.
significant.
And it often operates from really austere forward locations off amphibious ships. Plus, it can be refueled in the air, which gives it incredible reach.
And it replaced the old CH-46 Sea Knight, didn't it?
It did. And it brought a massive leap in capability, much faster, much longer range than the Sea Knight it replaced. It can haul, up to 24 combat-loaded troops or significant internal or external cargo.
So speed, range, payload, it changed how the Marines could operate.
Fundamentally. And its ability to operate in these spread-out coastal, littoral environments is absolutely key to their current big strategic ideas, like EABO.
EABO, Expeditionary Advanced Base Operation.
Right, and the stand-in forces concept. The Osprey's unique VTOL capability, combined with its speed and range, makes those concepts workable. It lets them insert, resupply, and move forces quickly in contested maritime areas.
So it's not just an aircraft, it's an enabler for their entire modern warfighting doctrine.
You could definitely say that. It's deeply integrated.
Okay, one more thing I came across was something called Project Eagle. What is that in relation to all this?
Project Eagle. That's bigger than just the Osprey. It's the Marine Corps' overarching strategic plan for aviation modernization as a whole.
So like a roadmap for all of marine aviation.
Exactly. It's a long-term vision, looking out over the next 3 multi-year defense budget cycles, starting in fiscal year 2026. It sets the direction.
And what does it cover? What are the main components?
It's broken down into 5 main lines of effort. First is concepts. This involves exploring future operating ideas like DAO, Distributed Aviation Operations,
Distributed Ops. Oh.
and DCAO 2040 Decision-Centric Aviation Operations. These are all about fighting effectively when forces are spread out and making faster, better decisions.
Ties back to EABO and operating in dispersed ways. Makes sense. What else?
Second is functions. They're reviewing the traditional 6 functions of marine aviation, assault support, anti-air warfare, etc., and seeing if they need updates for modern maritime fights and joint operations.
Adapting the classic roles. Got it.
Third is building a digital data-centric culture. Basically, fully embracing digital tools, AI, data analytics within the aviation combat element to make them smarter and faster.
Okay, digitalization. Common theme everywhere now.
Very much so. Fourth is the budget piece, the 3 Future Years defense program. This is about aligning the money, the resources, across those next 3 FYDP cycles to actually fund the vision laid out in Project Eagle.
The practical side, where the money goes.
Yep. And the 5th line of effort is roadmaps. This is where they develop the detailed plans for specific areas. Things like future vertical lift development, which is where NGAS fits in.
Okay, so NGAS is part of a Project Eagle roadmap.
Exactly. But also roadmaps for unmanned systems, for aviation command and control, for sustainment strategies, for the infrastructure needed to support it all. It's very comprehensive.
So Project Eagle provides the grand strategy, and things like V-22 modernization and the NGAS program are specific elements nested within that larger plan.
Precisely. The V-22's projected service life out to 2055, supported by all those upgrades we talked about, that all happens under the umbrella and guidance of Project Eagle.
It really pulls everything together. It's clear the V-22, despite, a sometimes bumpy road, is still incredibly important.
Undeniably. A unique capability facing challenges, but with a clear commitment to keeping it relevant and safe for a long time to come.
And the planning for what comes after is already well underway within that broader strategic view.
The story of the Tiltrotor is definitely far from over. These efforts in modernization, the safety focus, and the forward look with NGAS show a real commitment to evolving that critical assault support capability.
This has been incredibly insightful, really helps understand the full scope of the V-22 program, past, present, and future. Thanks for breaking it all down.
My pleasure. It's a fascinating and complex topic, and one that will keep evolving, I'm sure.
No doubt. Well, that's all the time we have for this particular breakdown. What are your thoughts on the Osprey's future? We'd love to hear them. Please comment and share. And don't forget to subscribe to the Military Breakdown podcast for more deep dives into military tech and strategy.
And check out our archives for other episodes, too.
Definitely. Thanks for listening.